Welcome to this video tutorial involving leash problems and areas of sectors. Perhaps you would like to pause this video and try the problem before we discuss it. Notice a few things in this problem. First of all, we have a shed in the shape of a regular 18 gon with a particular side length of 28 feet. We also know that the leash in this case is 65 feet long. Now in this scenario, we said that you need to draw some form of a regular polygon. It does not have to be drawn perfectly to scale. That would be almost impossible to do. But don't overly obsess with it. Make it well enough done that we can see what's happening. That doesn't even look close to being a regular polygon, but it would be fine on any test or quiz or assignment. First, we're going to pick a spot where the dog is centered, where the leash is harnessed. Now what we're going to do is we're going to visualize how the dog would walk around the shed. So first, say it walks along the shed and keeps its leash pulled tight as it walks across the side of the shed. We know that the side length here is 28 and that the remaining portion of the leash would be 65 minus 28 feet. 65 minus 28 is 37. But now, the dog, we need to envision changing its direction at that next point, that it wants to continue walking along the side of the shed perfectly. It will go the 28 feet, but then it will have 37 minus 28, which is 9 feet, remaining of leash that it can use. So it will turn and go 9 further feet, but that's not enough to get the whole way across that side. We will then mirror what happens as if the dog walked in the other direction. So we will draw these in accordingly. Of course, on any graded item, your picture has to be accurate or reasonably accurate for points to be awarded in their entirety. Now picture the dog walking around with its leash pulled tight as it was going in a circle. It would be going in a circle then as best it could, and that's what the picture would look like. We are going to have a variety of sectors formed as a result of this picture. One of the sectors is going to be what's scribbled in blue right there. The other sector are going to be these two magenta ones, which this picture is not drawn particularly well, but those are congruent. And then the last item will be what I'm scribbling in red for the red sectors. Now, first of all, in order to determine some things in this picture, we will need to use our handy dandy angles and regular polygons formula, plugging in the fact that n is equal to 18. When we calculate that, each angle in our regular 18 gon turns out to be 160 degrees. We will use that to determine the measures of the other relevant angles in this problem. First of all, the angle right here that I'm drawing in blue would be 360 minus the 160, which is 200 degrees. Then, since we have linear pairs over here in magenta and over here in blue, we subtract the 160 from 180 and determine that each of those angles will be 20 degrees, here in magenta and over here in red. So now when we go to determine the area of this shape, the area is going to be a bunch of sectors. First in blue, it's some fraction of the circle times the area of the circle. Plus, then in magenta, we've got two of the same thing where it's some fraction of the circle times the area of the circle. Plus, then in red, we've got two of those sectors, which are the same thing, some fraction of the circle times the area of the circle. Now as we look at this picture, the angle in blue is 200 and the radius for blue is the entire radius of the leash, which was 65 feet. In magenta, our angle is 20 degrees and the radius is this portion right here. It's that 37 that was left over after walking along the first side. And in red, our radius is our angle is the 20, and our radius is this extra piece right here, which we saw earlier was 9. So once we have that all set up, please watch for the twos. That's one of the common mistakes people make is they don't include those twos when multiplying everything out. We could type that whole expression in our calculator and we get 7880.16. Please watch your units in this problem. The length was expressed in feet, so the area would be expressed in square feet. Our answer is 7,880.16 square feet. On problems of this sort, decimal answers are fine. We do not need to leave it in exact form.